Another performed experiment was to measure the flatness of the waters with the use of light. The researchers opted for the use of a laser beam because its beam of light propagates in a linear way and can reach long distances with minimal loss of potency. The laser experiment consisted of two teams positioned on opposite sides. One team emits a laser beam parallel to the water toward another team. In the spherical model of the Earth, it would be impossible for the laser beam to be seen on the other side, since the supposed curvature of the Earth would be an obstacle in its trajectory. However, if the Earth is not spherical and the waters don't follow its curvature, it would be possible to visualize the laser light on the other side, for there would be no obstacles in its path. For more efficient results, this experiment with a laser beam was performed at a great distance, in the tens of kilometers, because the greater the distance, the greater the curvature of the Earth would be in the spherical model between the 2 points, which would prevent the laser beam from reaching the other side.
As we had some difficulty in getting high-power equipment, we decided to design and build our own equipment with a great power that could achieve a far greater reach than the laser equipments found in the market.
The device emits several beams of light and is set to reach the programmed distance without expanding, with the focus point on an object on the other side. 2 points were chosen at the coast of Sao Paulo, one on the beach of Caraguatatuba and another on the beach of Ilhabela. The team prepared the equipment during the afternoon to conduct the experiment at night. The devices are positioned at a height of 1 meter above the water level, directed towards the team on the opposite side.
The whiteboard or light receiver is 1 meter from sea level. The distance is 15,000 meters, 15 kilometers.
With the equipment ready, it's time to start the experiment.
South, 43 degrees.
This is the moment of truth. If the light is not visible on the opposite shore, it will be an indication of the sphericity of the Earth.
Down. Try to go down more. All right, this position is good. Try to level it out for now. There, a little bit more, a little bit, there.
Did the laser light hit the other side, which would question the theory of the spherical Earth? The team's next step was to repeat this same experiment over longer distances. To continue the research, Lake Titicaca was chosen on the border between Peru and Bolivia. One team was in the town of Juli in Peru and another on the beach in Copacabana, Bolivia.
Lake Titicaca has a width of 65 kilometers and a length of 165 kilometers. Other people say that the lake has spines, but it has not. It's a flat surface. It is a mirror Lake Titicaca here in Peru. If you look, for example, 30 to 40 kilometers, the lake looks flat.
Will the researchers be able to prove the flatness of Lake Titicaca?
We got here on the site, right on the side of the road. Down there in the center of the display is the town of Copacabana. For me, From what we are seeing here, the theory of water flatness is very convincing. But we will seek more evidence. It needs more results. We are Team 2. Team number 1 is in a town called Huli, also on the beach of Lake Titicaca. So here we are on the same level as them. There, team number 1 is approximately 2 meters above the level of Lake Titicaca. We are here 1 meter and 35 from the sand, and about 40 centimeters from the water level, as you can see there.
The teams are in position. All equipment has been checked. And the experiment begins.
That's good. Leave it there. We're pointing the laser.
The laser is then fired.
It hit it. There. To our right. To our right. A little bit to the left. Right there. We will blink.
Could the laser be visible on the opposite sides, which would prove the flatness of the waters?